All right, everybody. In this video, we are going to be setting up our breadboard to mimic this one with the different voltages here. And we are also going to be setting up our power supply. This one here uses 6 AA batteries. We are not going to be using batteries for our projects. Just a AC to DC adapter that can plug into the wall. And we are also going to be installing a power switch of our own. So this is a little more intricate than, usually when you start the book, you're going to be starting off with like learning how switches work. So this is going to take a little bit, it's still basic electronics, but it's going to be a little more than basic, I guess. We have to do a little bit more that's involved before we start learning about all these basic functions, but it's just to set up our board, and hopefully I can do a good job explaining it to you. So let's get started with that. If you look closely, this breadboard right here, we have a ground rail right here. This is the symbol for ground. And then we have our positive rail up here. This gives us 6 different voltages. 3, 4, 5, 6. And they are in 1.5 volt increments. 1.5, 3, 4.5, 6, 7.5, and 9. If you did not know, a AA battery has 1.5 volts, essentially. So that's why it has 6 different AA batteries. Each one is giving us the 1.5 volts, and all put together, that's how we get the 9 volts. So let's go ahead and open this guy and kind of see what's happening. We'll look at the power switch, and we will look at how we're getting power to supply this guy. Alright, let's open it up. Let's see what we're looking at. You guys are going to get real familiar with this thing real quick. So, let me explain some of what's going on here. This right here, this is where our batteries go. This is our power switch, and this is our breadboard. So let me do my best and try to explain to you what is going on. All right, the first thing I would like to note is that let's start with our power. So so there's like 2 holes basically. And we got 6 of them. That's for each battery. Only this battery has a top and a bottom connected to it. This black wire right here is our ground, or a negative connection. So if you see here, this is going to our switch, and then out of our switch is the other black wire. And if you follow that, that is what this whole thing is, our ground rail. So the power switch is connected to our ground rail. Remember that for later. So this switch here is the same as this switch here. These are double pull, double throw switches, but this one, it's all used for projects later on, but this one, only a portion of it is used. this double pull, double throw setup is really just a single pull, single throw. Let me try to explain it. When we're in the off position, we are connecting these two terminals. Well, there's nothing here. So that's how it's off. When we flip the switch up, we are now connecting these two together. So now the electrons more or less can flow through our black wire right here. And now that the switch is on, that allows them to flow from this terminal to this terminal to our negative. That's how our power works. And then, if you notice, each one of these is tapped onto a positive side of the battery. So, batteries are like installed one way and then the other way and then the other way and then the other way. So, if you look here, this white wire is our 1.5 volts. So, this is battery 1, battery 2, battery 3, battery 4, battery 5, and battery 6. 1, 2, 3, 4, 5, 6. So that's the same. This is how we're getting our 1.5 volts. This is also 1.5 volts, but now it's all connected. So that's 3 volts. And then we're going to go up here as 4.5 volts, 6 volts, 7.5 volts, 9 volts, if that makes sense. These color wires, they're just tapped at different locations. But we're using 6 1.5 volt sources connected in series, giving us a total of 9 volts. It will all make sense later. If that's not clicking to you immediately, do not worry. We're going to be looking at schematics instead of just these wires. So, in fact, let's go ahead and let's go head over to the schematics right now. All right, everybody, let's take a look at the schematic portion of this. So before I get into this, I want to emphasize that you guys do not need to know what's all going on here. This is a little more advanced than the beginning of the book. The purpose of the whole RadioShack thing is so that you can just plug in batteries and start learning. We're going to have to do a little bit more advanced techniques before we get to the fundamentals. So if you don't get this, if you want, feel free to skip it and just build the board with me. But this is good stuff to know. I just want to explain to those who do want to know the how and the why I'm setting up the board the way that I am. So let me go over the schematic here and what we've got. So I got my 9 volt DC power supply here, just like the AA batteries hooked up in series would provide me. I have the switch. And let's see. So I know that I have a 9 volt source. I know that I'm going to need 6 1.5 volt loads, essentially. That's what the RadioShack kit has. So, I'm going to need, if I have 9 volts and they're all 1.5 volts, then that gives me 6. I need 6 of them. So that's how I have 1, 2, 3, 4, 5, 6 resistors all hooked up in series. That's how I got that. So now I'm going to show you guys that this is all going to give us 1.5 volts each one. So now if I simulate this, I want to see my meters reading DC voltage, and I'm going to power on my circuit by closing the switch. I now have 1.5 volts. Cool. That's across one resistor. So now, if I go across 2 resistors, that's going to give me 1.5 plus 1.5, so 3 volts. And across all 6 resistors, we would then expect to see 9 volts. There we go. So that's working as it should. Don't worry about this right now. This is a watt meter. I'll get to that later. Just pretend this is right here. This is hooked up just like all these other resistors. Like there's just a wire here. So I know that I have on hand some 1/4 watt resistors. I do have some 1/2 watt resistors, but 1/4 watts are. I'm gonna try starting working around with just 1/4 watt resistors. So what does that mean? It means that each resistor can handle 1/4 of a watt, or 250 milliwatts. So let's see what I know then, that I know my power and I know my voltage. That means I can find my current. So if I know that each resistor can handle 1/4 of a watt, and then I'm solving for current, then I'm going. Sorry, I forgot to explain real quick for those that don't know. These are Ohm law equations. V is voltage, I is current, R is resistance. We'll go over them later, but I just put them up here for you guys to see, so you know what I'm doing. If I want to solve for current, I'm going to isolate the I, so I can just divide both sides by V. So it'll be P over V equals I. So 1/4 watt divided by voltage is 1.5. That means that each resistor can have about 167 milliamps going through it for the limit. I don't want to push this thing to its absolute limit, so I'm just gonna go for 150 milliamps for a limit. These things have tolerances too, but again, I don't want to exceed limits or try to push them here. And again, nothing is concrete. This is all just experimental. We may change this later, but I just want to show you how I arrived at this configuration. So I'm going to, let me type some of this out real quick. So for power's sake, we know can have up to 1/4. I have 1/4 watt resistors. Current maximum is 167 milliamps, and my voltage is going to be 1.5 volts. Okay. So that means I'm gonna toy around with the idea of 150 milliamps. So I'm not pushing the limit. So with that, I can then solve for the resistor value. Because right now we just know we need 6 of them. We don't know their values. So I can go to R, resistance, and that equals voltage divided by current. So I know that each resistor is going to be 1/2 volts, and that's going to be divided by current. I want it to be 150 milliamps, so 0.15, and that's how I got the 10 ohms through each resistor. So my real power then, this is max rated. So my real power will be P equals V times I. So it'll be 1/2 volts times 150 milliamps. So 0.225. So that's under 1/4 watt. Cool. And guess what? If I run this right here is you see the V, so it's a voltmeter and a current meter. And then it's just multiplying them together. So voltage, I'm measuring across R6, and then my current is reading between R5 and R6. So if you can see, I'm getting 225 milliwatts, and that's what I expected to see here. I have a probe connected as well, and you can see that's reading 150 milliamps. So everything seems to be looking good. And next, now that we've got this all configured, we are going to be actually putting the components onto the breadboard. So let's go ahead and check that out. All right, everybody. So here is our board. Let's get started. Real quick, you don't need a fancy one like me to get started with this whole back plate and everything like this, or you don't need these. Really, you just need a couple of these guys. What's cool about these are they're like Legos. You have your inserts right here, and they'll just snap together, so you can have your power rails and then all your other spots. So you can build this setup, is what I'm trying to say, without the back plate. You don't need the back plate. Here is my 9-volt barrel connection. That's what we're gonna be using for power. And then I just bought this adapter. So the barrel will connect into here, and then I just installed 2 wires that we're gonna be hooking up to our power rail. So let's zoom in here. So if you remember, let me get this on camera. Our power came in, so this is our batteries, and then they went to a switch. Here's our switch. We have on and off and 6 pins, just like the other one had. This is a double pole, double throw switch. So if you remember, from our power supply or the battery pack, it went to the middle switch. So I'm putting this one here in spot 2. And then the top one is going to be going to our negative rail. Connect just like that. So I can move it over one real quick so I can show you what's going on. So when I have this, where are my tweezers? When this is in the off position, the bottom legs are connected, and if you see, I have nothing right here, so nothing's gonna happen. And then when I slide this up, then these two are going to be connected. I could ohm that out to show you, but that's hopefully that makes sense after everything we've looked at. So when this is off, we'll be getting our power in right here, but then nothing will happen to it. And then when we power it on, electrons will be able to flow to our ground rail, completing the circuit. So let's go ahead and start adding some components. Always remember to put that in the off position. So we are going to want to bring it in from our power rail. And now what am I going to be doing with that? Well, I have here 6 10-ohm quarter-watt resistors. I think later I might upgrade these to half-watt resistors, just so we're not so close to the limit. And I don't know how much current some of these circuits are going to pull. This is not a concrete build. This is a learning experience for all of us, and this is just what I've got to get us started. So I'm going to start installing these just like we had on the circuit. So from our positive side of our supply, we're going to go through R1, okay, and that's going to connect to R2, R3, R4, R5, and R6. And then lastly, we want to complete our circuit. So this will be going to our ground rail. So if you guys don't know how breadboards work, the power rails, these guys on the side, go up and down. So red will be all positive, blue will be all negative. And then the way the portion of these breadboards and how they work they're going to be going this way. But there's this break. So I can basically tap on to any three of these points. This connection, that's how like this one is connected to this one. All this in the same is going to be the same. But if I want to extend this, I can simply just add a little wire jumper to here, and that gives me 4 more points to jump onto. And I can add a wire right here to go right here, and that will give me another 4 points to jump onto. You know, that's how quick explanation as to how breadboards work. So this is what we have. Our power switch is off. My 9-volt supply is plugged in right now, and I am going to be running some tests to show you guys. We're going to be measuring voltage, current, and voltage at several different locations, and then we'll do current measurement once, just to make sure we have everything operating the way that we want to. So let's go ahead and get started. Just double check real quick. Switch is off. Okay, I'm gonna bring in my 9 volts. Okay, so where do we want to start? Let's go ahead. I'm just gonna I'll show you what I have here. Just a little jumper wire that we can tap onto. So here's our ground essentially. So here's one resistor. Make sure not to short these. So from here to here, this is across. This is going across one resistor. That should be 1.5 volts. And now if I tap from here to say here, that's 1, 2, 3, 4 resistors. So this should be our 6 watts, or sorry, 6 volts. And then 7.5 volts, and all the way up here will give us 9 volts. So just connecting my meter real quick. So circuit is still powered off. Right now I'm going to switch to voltage and DC volts. Right now everything is off because the switch is off. So I should not be getting any voltage currently. Okay, 0 volts. Now I'm going to turn this on. And there we go. We have our 1.5 volts. Now, if I were to move it up to here, I said this should be 6 volts. There you go, 6.5, or 6.05, sorry. And all the way up here will be our 9 volts, because we have 6 1.5 volts consecutively. So we're at a little over 9 volts. That's okay. Great. So voltage is working how I want. Let's go ahead and power off our circuit. So with voltage, we measure across a component. Current runs through a component. The only way to measure current in this instance is to actually break the circuit and measure what's going through it. So let's go ahead and do that once, just to verify that everything's working okay and that we are getting our expected 150 milliamps. So to do that, I can break it anywhere in the circuit. Circuit powers off. Let's go ahead and break it right here. Great. Let me zoom in on that real quick. So I've broken the circuit, and I'm going to switch my meter leads to measure in milliamps. Oops. Let's try that. And I can. Okay. I'm going to switch my meter to measure in current, milliamps, and I want DC. Okay. Make sure everything looks good. And so when I turn this on, I should see, we said 150 milliamps. Look at that, 146 milliamps. So we're doing good. We're safe. Turn this off. There we go. Our circuit's looking good. So we tested our voltage. We tested our current. Another thing that you could do, and probably should have done this before anything. Now looking back, is you can measure resistance. We can do that real quick though, so I can show you how to do that. Okay, so this you're gonna want to do with the power off. I'm off right now. So, you know, one resistor we expect to be 10 ohms. On that. I'm still in current. That's why I rarely measure current. It's really not safe, but I just wanted to show you that our math was correct. So don't forget that. So now let's go back. All right, so we see a short. All right, so we should see 10 ohms, right? Because it's one resistor. Pretty close. 2 ohms together, or 2 resistors, should give us 20. And all of them together should give us 60. So there we go. Everything is as it should be. All right, we got our board all configured. So now we can go ahead and start having some fun with things. I will see you guys in the next video, and we'll start with the fundamentals, and we will begin with learning about switches.